All right, folks, we're back. A little bit of technical difficulty there. Our next speaker is Steve Klabnik. He's going to be talking to us about Rust for Rubyists. And sorry, I didn't have my intro up here. Steve is a former Rails contributor and a member of the Rust core team, and the author of Designing Hypermedia APIs, Rust for Rubyists, and Rails 4 in Action. So welcome, Steve. We'll let you take it away from here. Steve, can you hear me?
Hey, hello?
Is this there on? We go.
Hey,
yep.
It said that I was muted, and then I thought I was unmuted, but I guess not. Cool. Okay. Hi, everybody. I'm Steve. After some small difficulties, I finally made it here. I want to say thanks so much for having me. I think this idea of having a remote Ruby conference is super, super cool. Partially because I am sort of at a Mozilla all-hands conference in Vancouver, so this is like conferenceception for me. Which is kind of fun. I had some momentary technical difficulties. I'm sorry you had to wait on me, but I'm borrowing someone else's computer, so this is going to be a little bit rough in the sense that I don't actually have Rust installed, and I want to compile some demos. But as I like to say, I use Linux, and I love free software, but free software doesn't always love me. So I apologize for that. I should have been a little more better prepared, but I thought that it was working, and it just turns out it was not working at the last minute. So. Okay, so I'm here today to talk to you about Rust and Ruby. I'm going to do all my slides in Vim as markdown files, so you can sort of just see these. I have them in order, so I'm just going to go through them, and then I'll load up an editor and also show you some code as well when we get there. But as you all know, Ruby is super near and dear to me. I actually literally have a Ruby tattoo. I've always loved Ruby and always will love Ruby, but it's important to not get stuck on one particular technology because different technologies are good at different things. And Ruby is wonderful, but it's not perfect for everything. And sometimes you need something that can complement Ruby's strengths. So I've been joking that I like Rust because it also starts with RU, just like Ruby does. Hence this line 5 of the of my initial slide here. But the theme of this talk, I guess, is a couple different things. Let me go to the next slide. So we're going to talk about 3 different things. The first of all, we're going to talk about what systems programming actually is, or what we mean by systems programming. That's sort of been this contentious topic recently. And so I'm not interested in saying this is the one way, but I mean, when I say systems programming, what do I mean by systems programming? And then I'm going to talk to you a little bit about Rust itself. And of course, introducing systems programming, I'll mention a little bit of things about Rust. But then finally, Rust and Ruby together. And why that may be an interesting combination, and why you may want to do that, and how your interest in Rust can complement Ruby, not necessarily replace it. Okay, so systems programming. Like most things in our fields, we are very bad at actually defining terms and what they mean and then using them consistently, right? So there are tons of terms in the programming world that are misused according to the original authors, and you can get into all these complicated linguistic debates. There's the prescriptivism versus descriptivism linguistic arguments. So a prescriptivist linguistic argument says that we needed to define our terms and lay them out. Everyone should be forced to conform to those definitions. A descriptivist view of linguistics says that we should be describing how people use words and that words change over time. And so lots of people think that things like dictionaries are descriptivist when actually, or they think they're prescriptivist when they're actually descriptivist. So my favorite example of this recently is that so many people have used the word literally to mean figurative, so includes a figurative usage. So I don't want to argue and say that a particular programming language is or is not a systems programming language, but when Rust describes itself as a systems programming language, I want to let you know what we mean by systems programming. And I have 2 shout outs to Yehuda in this talk. As the other big Ruby person involved in Rust, we agree on a lot of things. We spent a lot of time discussing this, so I want to give credit where credit is due. But Yehuda came up with this formulation that I really enjoy, and it's called systems programming is when it actually does matter. And what he means by this is that when we're doing stuff in Ruby, we often say things like, Ruby is slow, but it doesn't actually matter. And Rails is a bit bloated, and sometimes it's hard. You get a monolith, but it actually doesn't matter. Things like Ruby uses a lot of resources, but that doesn't actually matter. And so systems programming is any sort of programming that's in a domain where you can't say that it doesn't matter. So there's a lot of different things that could matter to you very strongly. There's sort of three big ones that I've outlined here. The first one is memory usage. So a Ruby process uses about 35 megabytes of memory, last I checked, just from loading up the interpreter. As soon as you start requiring Ruby code, it uses more memory. It's not uncommon for Rails processes to use 200 or 300 megabytes of memory. And there's a lot of good things that come out of that too, or at least for us as a programmer. But it also means that we spend a lot more money on servers and have to do things like move to SOA, or come up with all of these ways to lay out a ton of servers due to Ruby's high memory usage. Speed is another thing. So the very, very first Rails app I ever built actually included a C extension because I needed to do file processing, and it needed to be very fast and do a lot of complicated math. And so this is another area where most of the time Ruby's lack of speed is totally not a problem, right? And it sort of comes with the memory using too. Matt designed Ruby to be good for humans and not good for computers. That's like part of the thesis of Ruby, is that computers will get faster, and so we should optimize our language for humans. But every once in a while, unfortunately, computers take precedence, and so you might find yourself in a domain where that matters. And the last one is control, and that's sort of control over these different kinds of things. So you want to be able to say, like, I don't really care about memory usage, but I do care about speed, or I need this particular kind of thing to be laid out in memory in this particular way, because that makes a performance difference. I recently saw a blog post, and it was about OCaml, not about Ruby, but if you went from 13 to 14 local variables in a function, the function would get 2 times slower, even if it wasn't actually doing anything, just declaring one extra variable made it slower. And that's because the underlying assembly language that needed to be done under the scenes, once you got to 14 variables, it started to have to shuffle things in memory, and that made things more slow. So occasionally you need to control these kind of low-level details, and so that's what we call systems programming. So it's not necessarily even about low-level stuff necessarily. It's more about this dichotomy of speed and control. The other thing that I want to say from Rust and also to Ruby people as well on both sides of this divide, a lot of people think that systems programming and low-level programming is like hard. And so they're intimidated by the idea of doing this low-level programming because they think that, I'm not that great at Ruby already, so how could I ever do C? Or, I would like to maybe think about operating systems, but that seems really complicated. I'd rather stick to web applications. And what I would like to remind everyone is that humans are different from one another, and we all have our own strengths and weaknesses, right? So, for example, I have found out that my strength is in writing documentation, and so that's what I've been focusing on lately. Other people are bad at documentation, but are really great at bit twiddling or like dealing with like these bit level representations of stuff. Other people are really great at high-level design, and other people are great at interface design. So I think that painting certain kinds of programming as being easier or harder is kind of false, because it may be easier or harder for you, but it might be differently easier or harder for other people. So I've actually talked to people before who say that Rails is harder than assembly language. And at first I want to laugh about that, but their point is like assembly language consists of certain low-level instructions that do exactly what they say on the tin. When you say add this number to the value in this register, that's what's going to happen, no questions asked. And when you're building accept a network connection on my computer, I'm going to run an arbitrary program that's going to talk to a database. It's going to combine all these things with like millions of lines of code. It's then going to produce a markup language and a Turing-complete programming language and a styling language and jam them all together and send them back over to another computer on the other side of the world. And that in and of itself is incredibly complicated, whereas assembly language is very straightforward. And so I think that this illustrates that for some people, you might actually find that low-level or systems programming is easier for you than web programming. And that's sort of interesting, and I think it runs contrary to a lot of the accepted programmer wisdom. We think about, lots of people like to deride web programming as being somehow lesser than assembly hacking or working on operating systems, but I think in some ways it's harder. So I would like to encourage you, if you have any interest in this kind of low-level programming that's different than doing web stuff, or we all know Ruby is not entirely just used for web stuff and Rails, but if this is interesting to you, you shouldn't let it intimidate you. And specifically, not only should you not let it intimidate you in general, but Rust and its community will happily welcome you with open arms and help you understand this kind of low-level programming stuff. I myself used to do low-level programming things a long time ago. C was actually the second programming language I've ever learned. But as soon as I found Ruby, I said, I don't want to do that low-level stuff anymore. I'm going to just use Ruby all the time. And that's been cool, but for me, Rust has been about relearning this kind of low-level stuff. And I can tell you from experience as a Rubyist who came into the Rust community, they're absolutely perfectly happy to explain any kind of thing that you don't understand. And there won't be any of that kind of machismo or derision towards people that have inexperience with programming at the low levels. They actually will be happy that you want to do the kind of programming that they care about. And so that's sort of the position that we take in Rust. And so you'll find that pretty much everyone is.
Why don't you go ahead and then people can pick up where they left off on the recording if they missed something.
Sounds good. So yeah. Okay, I think wherever I dropped off was actually sort of the next slide, because when I transitioned to it, this is actually what I was just talking about. So I'm just going to do that. Okay, so this, and then this one. All right, so if anybody does these comparisons, you should, if anyone says that you can have your cake and eat it too, then they're lying to you, which is what I just said. So what's the trade-off? As an engineer, we should always worry about the trade-offs. So the way that Rust deals with these trade-offs is having extensive compile time checking to ensure safety rather than runtime checking. So since it's a compile time, you still get the safety, but you don't pay for runtime overhead, so it still get the speed. The downside is this thing we call fighting with a compiler, or I like to say a conversation with a compiler. So it's a little harder to get your Rust code to initially work because you have to deal with these checks and you have to learn what they are. So a lot of people describe their first month or so with Rust is kind of frustrating at times. But then at some point it clicks and they stop having those kind of problems and they just cruise along. So I personally feel like I'm probably about 80% as proficient with Rust as I am with Ruby. And that 20% is sort of this overhead that I pay by dealing with a more complicated language. But the advantage is that my programs run significantly faster. And I can also do extra things that I can't do with Ruby. And so I think that you have to kind of look at it as not fighting, but having a conversation. The compiler is there as your friend. Every time it doesn't let your program compile, it's telling you that there's a bug that it solved that you didn't need to debug later. So that's kind of the way that this sort of feels. Okay, so that's some background about Rust in general. Now let me actually show you some Rust code. I'm going to start off by showing you some Ruby code, actually. Let's actually, I'll show you the Rust Hello World, since I'm required to show you Hello World as first in any programming language, right? I'm not going to spend a whole lot of time going over Rust syntax, but I just want to show you a little bit of what it looks like. So, and there's not going to be any syntax highlighting because, again, I'm borrowing somebody else's machine, so sorry about that. So this is Hello World in Rust. We have a main function that gets defined with the fn keyword, and then you can use println to print out Hello World. You may see that we include the parentheses and curly braces, which is a little different than Ruby and is more like something like JavaScript or C, but it ends up not being too bad. If you're declaring things like variables in Rust, while we are static typing, we do have full inference. You can say let x equals 5, and this will actually give you a 32-bit integer named x, but you don't need to declare the type here. If you notice, Rust will infer that automatically. So if I wanted to type out the full type, I could write this, but you don't generally need to. And what this means is that Ruby, in the sense that you don't need to constantly be declaring types everywhere. It just kind of works out. One area where we do force you to declare types is in function definitions. So if I'm making a function foo that takes an I32 and returns an I32, then it looks like this. And so you do have a little bit of type signature stuff here. I'm actually really excited to see Ruby gain gradual typing stuff, and this is an area where I think the Ruby community is sort of starting to pay attention to. If you want to check out what's happening in Ruby world, Tom Stewart has been doing a number of wonderful conference talks about what static typing would mean in Ruby and a little bit more about static types. But Rust sort of gives you this thing where you pretty much only declare types in the function signatures, and it does inference everywhere else. So that's really nice. Okay, so with that being said, I'm going to show you some that has a problem and how that Rust code solves it. Okay, I'm getting a weird click noise. I don't know what it is. Hello.rb, oh, whatever. Okay, so this is some Ruby code that deals with threads. And what happens is we declare this variable x, we set it equal to 5, and then thread.new do x plus equals 1 end. So in the thread, we're going to add 1 to x. And we have a handle, so we print out the value here and then join on the thread and then print out the values. So this on my machine usually prints out 5 and then 6 because the thread doesn't run until we actually hit the join. And so this is totally fine, but as we know, shared mutable state is the root of all evil. So the problem here is that if I were to modify this code to do something like this, and then add another join here, it's possible, and it depends, like this will actually, it reproduces more often if you add like a sleep here. But the point is, when I added semicolons, because I've been doing so much Rust lately. So the thing is that this is non-deterministic. So depending on how long each of these threads takes to execute, like if this takes 10 seconds and this takes 5, then you might get it, each thread will happen in a different order. And depending on if these threads run before or after the puts, sometimes you'll see put 6 and 8, and sometimes you'll see like 5 and 7, and it's like whatever, like the 2 increments can happen at different times. And so this is a big problem with shared state. And so languages like Ruby don't really give you a whole lot of help. They just sort of say you have to be careful when you're doing threading and make sure that you use the proper concurrency primitives. And so that's just kind of the way that it works. And so if we turn this program into a Rust program, this is the same thing in Rust. So you can see there's a lot more punctuation. Unfortunately, Rust has a little more punctuation heavy than Ruby is. And threading is a standard library thing, so you have to use standard thread. But the first thing I want to point out here is that we actually have to declare x mutable in the first place. So variables are immutable by default in Rust, which is kind of nice for a number of different reasons. It makes sure you don't accidentally change things, and it lets us optimize more. But so we said that it's mutable, and then we have this thread spawn call, and it adds 1 to x, and then we join on the handle. The unwrap basically says if there's an error, just crash. Ruby lets us ignore the result of join entirely, but in this case, we have some error, and then we could print out x. X goes in between the two like curly braces there, basically is what happens. So this program is the exact same thing as the Ruby program. It does the same thing, but it will refuse to compile. And so Rust will give you a couple different errors, but I would show you what the exact error is, but like I said, I'm borrowing someone else's computer and I don't have Rust installed, so I'm sorry. But the error will basically say, you've already used X in another thread, so you're no longer allowed to use it in this original one. Rust can actually track that you've sent a reference to a variable into another thread, and it just straight up won't allow it, because that leads to these really hard to debug concurrency errors. So what do you have to do? Well, that's the thing. So I have the sort of fixed code here. As you can see, there's a significant more amount of complication. What you have to do is you have to use these two things called arc and mutex. So arc gives you atomic reference counting. This is something that's heavily used in languages like Swift, although the Swift's arc stands for automatic reference counting, which is a little different. But their automatic reference counting uses atomics, so it's like the same A. Again, names are really hard, right? But this will give us a count of the number of references we have to something, so that we're allowed to have more than one reference. And then a mutex will require only one thread to access it at any given time. So we wrap up our value inside of a mutex and inside of an arc. On line 7 here, we use clone to say, give us another reference to this arc. So now we have 2 references, x1 and x2. Inside the thread, we actually call the lock method on x2, which locks our mutex and gives us access to our value. And then here we add 1 to that value. And then once this happens, when x3 goes out of scope, the lock gets released. And when the thread goes out of scope, the reference count goes down. And so now we know that we're able to do this across multiple threads properly, and we can join the same way, and we have to access the lock again to print out the value. And so this is what I mean by being a little more complicated to do in Rust. The thing is that Rust does not let you be sloppy. Someone wrote a blog post called Rust is the anti-sloppy programming language, and I think that's very true. So what's the nice property of that is you can know that once your code compiles, it definitely works. But the downside is that you have to know how to write all this stuff, whereas Ruby would sort of happily let you do something that is not actually safe. So that's sort of the trade-off. Choosing different languages, you have to sort of decide, like, is the safety worth it to me to have to write all this extra stuff? And sometimes that answer is yes, and sometimes that answer is no. It all just depends. Another thing that I want to show you about Rust that sort of helps Rubyists feel at home is cargo. So where's this new tab button? I guess I'll just new window. I'll just do that. So we have this package manager called crates.io. Make this bigger so that you don't have to see all the chat being repeated everywhere. And so cargo and crates.io is the equivalent of rubygems.org and bundler. So we actually had Yehuda write bundler for Rust, and so we have literally the same thing. So you can see like downloaded packages, and this sort of works the same way. I'll show you the, since I don't have it installed, I will show you the guide real quick because that will have the commands on it. So, just like you type bundle new, you type cargo new, and it gives you a little directory. We use TOML instead of Rust for our files. So you sort of add in the package metadata, and then when you type cargo build, it compiles your project and it runs it automatically. You can type cargo run to do the debug and the build. What's really cool is adding dependencies. So just like in Ruby, we can say, this depends on Rails version 4.1 point whatever. We can do the same thing in Rust world by saying that time is equal to this particular version. And it does the exact same thing that bundler does. It figures out all the sub-dependencies and all the versions. It generates a lock file, and it does all that. And so to Ruby people, that seems like normal going. But if you've ever dealt with a C project before, managing these kind of dependencies is super, super hard. You're like writing makefile rules and git submodules and like hand verifying all the values or dependencies. And so what ends up happening is that Rust is much more like Ruby in this respect than it is like C, because it's very, very easy to write packages and share them with other people. And so as you can sort of see from the front page, we have like 3 million downloads of packages already and 2,400 packages, which is still not very many by Ruby terms, but for our languages hit 1.0, that's a pretty large number of packages, and I'm pretty happy with the way that this has sort of worked out. I've had a number of people come from the sort of C world, and their minds have been blown by this. Before I told you about how the Rust community was welcoming to Rubyists who want to get started doing systems programming stuff. So the way that the Rubyists have helped taught the C programmers stuff is like how this works, right? So I've had people say like, oh man, you've been teaching me so many things about low-load programming. Now I finally get to teach you about dependency management. And so this is one of the reasons why I love working in different programming languages, is that we all get to teach each other different things that we're experts at. So in this case, this is the area where you can help teach the C++ programmers how things work and how wonderful that is. So that's kind of fun too. And it's something that definitely makes me feel really at home in Rust, is that the tooling is very similar to the tooling in Ruby. And that's been a really big, nice benefit. Okay, so let's delete these buffers. All right. So, okay, so I've told you a little bit about Rust and why you might want to use it. But the thing is as I've mentioned, Rust gives us certain trade-offs. We may not actually want to use those trade-offs. We love writing Ruby, right? Like that's why this is a remote Ruby conference. And so what I'm here to tell you is that you don't have to actually stop using Ruby to write Rust. And that's because you can write Ruby gems in Rust. So the thing is that Rust can pretend to be C in terms of building a library. So you can build a Rust library and then use these annotations, and it will pretend to be a C library. And since Ruby can FFI into C, it can also FFI into Rust. And so I also want to bring up a different window. I'm going to do another new window here to show you this because it's actually in the documentation. So rather than, let's see, docs.slang.org, rather than, it's doc, I always forget which one it is. Rather than make a slide out of this, I just wanted to show you where it is in the documentation so you can check it out later. So I wrote this chapter called Rust Inside Other Languages in the official documentation. And what that lets you do is it shows you how you can write a Rust program and then call it from Ruby. So this is a thing that spins up a bunch of threads. It counts to 5 million. It just does useless work. And I chose this example because Ruby has a GIL, so it limits our ability to run threads in parallel, but Rust has no such restrictions, so it's significantly faster to do it this way. And so all you have to do is add extern function instead of function, and add no mangle instead. And those are annotations that basically says, hey, in this, I won't bother with those right now. And then you add this information to your cargo toml, which is the equivalent of the gem file, and you say, like, I'm going to build a dynamic library, and then that gives you a embed.so file. And then you can load that up the same way as you would in Ruby. So here's the FFI code. You can see that we have a module. After we require the FFI gem, we can extend FFI library and then load up the direction to that object, and then say, here's this function. It takes no arguments and it returns nothing, and then call hello.process, and this will call into the Rust code. And so this is really cool because we've always said that Ruby is slow, but when we need speed, we'll drop down into C. But then we don't actually drop down into C because C is terrifying. So one of the messages of this talk is that I would like you to consider saying in the future, I like to write my code in Ruby because Ruby is wonderful, but it's slow. So every once in a while, I drop down into Rust when I need speed. And so I think that's a really powerful thing in the future for Rubyyists to get this kind of assistance. And this was actually one of the first production usages of Rust. And this is why Yehuda is involved in Rust, is because Skylight.io is Yehuda's project that it profiles your Rails app and then gives you information on it. So they actually wrote so you install this gem in your Rails app and it does the monitoring. So they wrote the initial version in Ruby, but they had several problems with using Ruby for this purpose. The first one being that GC pauses would interfere with their timings. So they started turning the GC on and off, and that got a little weird. And there were memory leaks and other issues. And so they're like, well, I guess we should write it in C instead. So they did a version in C, and Carl and Yehuda both said, I'm not confident that this code actually works. It's really hard because, again, if you get a seg fault, you crash the Rails app entirely. So they said, like, do we really believe in this code well enough that we would want other people to install in their applications and that we're not going to crash them? I don't know. And so then they tried out Rust, and they felt much more confident using Rust. And so now when you gem install Skylight, you get Rust code. And that's an example of Ruby and Rails and Rust actually playing together in production. It's been working really well for them. And they said they couldn't have done it without Rust. So, unless you're trying to make a direct competitor, it may not be exactly that. But like I said, I had a C extension for my first Rails app that was doing file manipulation stuff. So I can see things like rescue jobs being written in Rust. Instead of dealing with that like image resizing, image magic stuff, being in Ruby, you could just do that stuff in Rust. All those kinds of things. So that's an example of like why I think that this matters to Rubyists. And so I'm not trying to say you should stop writing Ruby and start writing Rust. I'm saying that you should use them together because more programming languages is always fun. There were some technical difficulties, but I think that I'm still maybe a little bit ahead on time. That's pretty much most of what I had to say. I guess I have a couple more minutes, so I'm going to show you one last really cool feature that I really like with Rust down at the bottom here. So Rust does not support OOP directly, but it does have sort of similar facilities. So what you can say is like struct point is X is an I32 and Y is an I32. And then you can say that I have a trait area, and this trait has one function area. And in Ruby, we have an implicit self, but in Rust, we use an explicit self, sort of like Python does. And so then you can say impl area for points. Since I don't have a lot of space on the screen, I'm just going to put it in one line. But area self And I'm not going to actually compute the area. I'm just going to say self.x because, whatever, this is an example. But the point is then you can do like let point equals points x I32 y I32 or 5 is number 5. Y is 5. And then point.area. And this will actually return that value. So this method syntax comes from this combination of a struct and a trait. So you know how we always say like data and behavior should be separate, but in Ruby they're all in the same class. So Rust allows you to sort of split up these things into the data, the behavior, and then the implementation of this behavior for particular data. The other thing that lets you do is write functions that are generic over a particular type. So for example, if I have this trait called data, I can write a function that says foo for any type t that implements area, and then x is a t, and write some code down here. And so this lets you do this kind of polymorphism that's like very useful in the Ruby world, but you don't have to write out all the types yourself. You can just say like do some code here. And so this gives you this like really great flexibility, and I've been really enjoying splitting up my data and behavior. And I think that it's a really cool way to sort of move forward. This is also ridiculously super fast. So other languages have similar features. Haskell calls them type classes. Go calls them interfaces. Scala calls them interfaces, I believe, as well. But in Rust, we do some low-level trickery that makes ours significantly faster than all those other languages' implementations. And I don't really have time to get into it right now, and I'm sure you don't really care at the moment. But I'll just say that like this is particularly super fast. Like C++ calls these things template parameters. And so we are in the super, super fast version of this. But it's a really nice way of modeling stuff, and it's really sort of changed my perspective on how you do this. And when Ruby gets gradual typing, I'm hoping that some sort of facility like this will exist, and that we'll be able to start writing Ruby code in this fashion too. Because if I could just say that I know this function always takes a string or something that accepts 2s and then get a speed up from it, that would be really, really cool. So anyway, that's my last example of like a cool little feature in Rust. Thank you so much again for having me. I apologize for the technical difficulties. And if you want to talk about this or anything else anytime, feel free to ping me as always, either at Steve Klabnik, because I'm back on Twitter these days, or steve@steveklabnik.com over email. And you can find, I guess I should put the URL for Rust. Rust is at rustlang.org. We also have users.rustlang.org as a forum, and irc.mozilla.org #Rust is the channel where you can get an IRC and get help from people, and that's super useful. And also Stack Overflow is a great place to ask questions. So yeah, thanks again so much for having me, and I look forward to the rest of Remote RubyConf.
All right, thanks, Steve. Does anyone have any questions that they'd like to ask?
I can see the chat, so I think the chat's working.
Okay.
Three people are typing now. You're welcome for JSON API, Simon. Now that it's 1.0, I'm really happy that finally it'll be good.
So one question that I have about Rust is,
Sure.
I've looked at it a little bit. I'm wondering a little bit about testing Rust.
Yeah. So basically, what happens is any function can be annotated with this test attributes, and then what happens is when you run cargo test instead of cargo run, and it compiles all these as tests and runs them. So what ends up happening is we just have the very basics like assert 5 or assert EQ, this and that, and this kind of thing. So it's a very basic bare bones testing thing. But essentially, this is all that it is, but it's built into the language. So almost everything has tests. The compiler has tons of tests. The standard library has lots of tests. One other really cool thing is documentation. So let's say this is a regular function, and we use a / for a dot comment in Rust. You you could actually, so we support Markdown in docs. You can say like, this is a title, but if I could spell title, that is. But we support these this Markdown, the triple backticks thing. So you can actually say like, this, that. And when you build your documentation, Rust will actually run all of your code samples as tests. So that's also really cool, in that all the examples are tested when you release things. And of course, not every code sample is meant to be runnable, so you can add annotations that say like ignore this test or whatever. But that's another. Those are the two primary ways that Rust code gets tested: is documentation examples and then using this sort of built-in basic unit testing framework.
Cool. There are a few questions in the chat now.
Yeah, okay. Will there be a Rust conference in Europe soon? So we're having the first Rust camp August 1st. Tickets just went on sale this year, and we want to keep it small and not try to go too big, and we don't have that much money. So next year will be Rust Conf version 1. I have some murmurs on the internet that some community members might be doing a European Rust conference. So I will keep you all posted if that becomes a reality. And so in theory, I guess if they start before we do, Europe might actually be first in terms of like Rust conferences. But definitely we're hoping to sort of have them across the world in the future, since
we lost him. Oh, he's back.
Sorry about that. My internet apparently cut out for a second. But yeah, basically we want to do it. We'll see how it goes. 1.0 got shipped a month ago, so we have a long way to go with the community stuff, and so hopefully it'll be a Rust conference. Can Rust cross-compile for Windows, Mac, or similar rate compiler? So right now, we do, technically every Rust compiler is a cross-compiler, so you can say, hey, I'm going to cross-compile from this to that. But right now, it's still not that great interface-wise. It needs a lot of love. So we're currently working on trying to make that as simple as in other compiled languages. The big problem is you need a pre-compiled version of the standard library for your target platform. And so we're hoping to, in the future, sort of have pre-built binaries for that platform so that it's much easier and to make the interface a little simpler. So the foundation for cross-compiling is all there, and it's definitely works. It's just not quite as simple. If you Google for like Rust cross-compile, you can see the kind of grossness you have to go through. But the start is all there. So yeah, it works. So tabs or spaces? It's not an infamous question because of course it's spaces. Why, if you use tabs, what's the matter with you? No, I'm just kidding. I mean, I'm not kidding in the sense that I definitely prefer spaces, but I don't think it's as big of an issue as programmers make it out to be. In Rust, we use 4 space indents, not 2, but there's a significant number of people that want 2, and so we're thinking about maybe trying to change the defaults. We're currently developing a Rust format tool that will automatically format your source code according to conventions, and so once that exists, we'll start to have hard conversations about what actual conventions are. But basically, everyone uses spaces for indentation in 4 of them. So that's what currently happens. Yeah, it'll be very similar to Go format. There's currently an argument about how much it should be customizable. I'm actually arguing that it should have no command line options whatsoever. It just does the same thing. So yeah, you were about to say something, Charles?
I was just going to say, so the compiler just sees it as white space at the beginning of the line and ignores it.
It doesn't. The compiler doesn't care. It works either way. The hard part about a tool like that and why it takes some time is that, so for example, we can definitely format like valid syntax tree stuff, but if you want good IDE integration and things like that, then you need the ability to work on partially formatted syntax. So similar to code completion, it's a harder problem than you might initially think. So it's taken a little while to build it, but we're in the middle of building it. Thank you for the compliments on the docs. I wouldn't be able to do it if Mozilla didn't pay me because it takes a lot of effort. And I have some other cool stuff that I can't quite announce yet that's happening with the docs soon, but keep your eyes peeled. Anything else?
I don't believe so. It doesn't look like there are any other questions coming in, so thank you very much. Oh,
Bill says, wait, one more.
We'll wait for Phil. Just Phil. No, I'm just kidding. Type fast.
I have to go to work after this, so type slow. Text formatting parsing capabilities. So, I guess, so in terms of, those are sort of two different angles, right? Producing and consumption. So there's a library called Serde, S-E-R-D-E, and it's sort of the next generation sort of serialization, deserialization format. So if your text is JSON, that is very, very easy. However, one of the guys who works on VLC, he lives in France. Actually, just got to visit him recently in Nantes. He has written a library called Nom, which is really great for a parser. And so it's actually a parser combinator library. And so it lets you write really, really, really efficient parsers. And so, yeah, so CSV and CSV-ish data, as you mentioned, there's both a good CSV parser that's built on top of Nom, and there's also a tool called XSV, let's type it in this chat, XSV, and that is like a super, super fast manipulation of CSV. And so, yeah. So using that as a Ruby extension, you might be able to find it out. The guy who makes it is Sushi CSV, but not 100% sure that if you look for CSV parsing stuff, and it supposedly works really well. Anytime.
All right. Well, we'll go ahead and wrap this up. I just want to do a quick call out to Steve. Thank you for coming and sharing Rust with us.
Yeah. Thank you so much for having me. I really enjoyed it.
All right. Well, I will be getting the videos up tonight. So you can all watch them then. I also want to do a quick call out to our sponsor, hired.com. So if you're looking for a job or know somebody who is, have them go check out hired.com/RubyRemoteConf. They have people bidding on developers all the time. And you can probably find something there. And if you take a job, you get a $4,000 bonus instead of the regular $2,000 bonus if you use our link. So go check that out. And thank you all for coming, and we'll see you all tomorrow.